A function is a mathematical relationship that maps each value of a set of inputs to a single output. The notation fx is used to represent a function of x. The set of possible inputs for a function is called the domain, and the set of possible outputs of a function is called the range. As you can see here, the diagram below shows how the function fx equals x to the power 2 maps 3 values in its domain to values in its range. So, in the domain, we have 3, minus 3 and square root of 2. To find the values in its range, substitute each of these values as x into the function fx. So, f3 equals 3 to the power 2 equals 9, f minus 3 equals minus 3 to the power 2 equals 9, f square root of 2 equals 2. Now, let's take a look at this example. So, here we have two functions, fx equals 5x plus 3 and gx equals x to the power 2 minus 2. To find the value of f1, substitute x equals 1 to the function fx. So, f1 equals 5 times 1 plus 3 equals 8. To find the value of g3, substitute x equals 3 to the function gx. So, g3 equals 3 to the power 2 minus 2 equals 7. f4 plus g2. Now here, first substitute x equals 4 for the function fx and x equals 2 for the function gx. Then you can add the two values of the two functions. So, 5 times 4 plus 3 plus 2 to the power 2 minus 2 equals to 25. The function f is defined as fx equals x to the power 2 plus 6x minus 5. As you can see here, this symbol means is a member of, and the symbol shown here represents the set of real numbers. If the input of a function x can be any real number, then the domain can be written as shown below. The solutions to an equation are sometimes called the roots of the equation. So now remember, the roots of a function are the values of x for which fx equals 0. To find the roots of the function fx, first set fx equal to 0. So I'll first complete the square for x to the power 2 plus 6x and then simplify the expression x to the power 2 plus 6x minus 5. So x plus 3 squared minus 14 equals to 0. Add 14 to both sides gives us x plus 3 squared equals 14. Now take the square root of both sides of the equation. So x plus 3 equals plus or minus the square root of 14. Then x equals minus 3 plus or minus the square root of 14. fx has two roots, minus 3 plus the square root of 14 and minus 3 minus the square root of 14. fx equals x to the power 2 plus 6x minus 5 is a quadratic graph. So I'll be covering quadratic graphs later on, but for now let's forget about it. Sometimes you're going to have to find the minimum value of fx and the value of x for which that minimum value occurs. Now remember, a square value must be greater than or equal to 0. So x plus 3 squared is greater than or equal to 0. Since x plus 3 squared is greater than or equal to 0, the minimum value of fx is minus 14. So this minimum value occurs when x plus 3 squared equals to 0. So when x equals minus 3. fx equals x to the power 6 plus 7 x to the power 3 minus 8. Here, you can treat x to the power 3 as a single variable and factorize. To make it easier and less confusing, replace x to the power 3 with a and then solve the quadratic equation in a. So, let a equals x to the power 3. Replacing x to the power 3 with a gives us a to the power 2 plus 7a minus 8. Factorizing a to the power 2 plus 7a minus 8 gives us a minus 1, a plus 8. To find the roots of the function fx, set fx equals to 0. So when fx equals to 0, a equals 1 or a equals minus 8. To find the roots of the function fx, set fx equals to 0. So when fx equals to 0, a equals 1 or a equals minus 8. If a equals 1, x to the power 3 equals 1. Then taking the cube root from both sides gives us x equals 1. If a equals minus 8, x to the power 3 equals minus 8, then x equals minus 2. Here the roots of fx are 1 and minus 2.